Welcome to the Guide to Building a Company Component Library. This course is a comprehensive guide to creating a private component library using React, TypeScript, Storybook, and GitHub pages. I'm Austin Green, and I'll be your instructor for this course. This course will teach you how to create a flexible, private, enterprise-grade component library using React. Since its introduction in 2013, React has become one of the most used front-end frameworks. Its component-based architecture and flexibility has made it the framework of choice for those needing to share code across multiple teams. However, the same flexibility that has helped React grow in popularity also creates many challenges when creating shared assets and tooling. Some of the most commonly asked questions include: what components should be shared? How do I choose which dependencies to include in my library? Which component APIs and design patterns allow for the most flexibility? How do I document and build my components? How should I be testing my library? And where do I deploy my components for internal use? During this course, we will create a shareable component library that includes identifying shareable components and styling from an existing codebase, creating an NPM package using TypeScript, ESLint, Prettier, and Storybook, implementing common and advanced shared component patterns, some common CSS and JS patterns using style components, testing components with React Testing Library, creating a tree-shakeable build process with Rollup.js, and deploying our component library to a private NPM registry using GitHub Actions. After completion of this course, you will have the knowledge you need to create a flexible and maintainable component library that is consumable within your organization. For some prereqs, this course is focused on intermediate to advanced React topics. You don't need to have years of experience for this course, but you should be familiar with React and other basics of front-end development, including HTML, CSS, and JavaScript. My name is Austin Green, and I'm a software engineer focused on creating the best shared developer experiences. I come from a full-stack background, but have been focusing on shared front-end components and tooling since about 2016. During this time, I've worked across many open and closed-source React code bases, and I've seen common patterns that can make or break the development experience for a library. For the past 3 years, I've been a core contributor to the open source Zendesk Garden design system, where I helped create shareable React componentry. If you have any questions about the course, feel free to email me at courses@austingreen.dev. Let's get started. The most common reason for implementing a component library is the need for consistency. By abstracting common business logic, styling, and features, you are able to provide a consistent experience for the end users of your product, as well as an improved developer experience for those building it. With the flexibility of React and the variety of library choices in the ecosystem, there isn't a hard rule of what should be abstracted into a component library. In this course, we will be focusing on techniques and API patterns that allow for the widest range of uses. When building a new library, the trick is to make it flexible enough to support the use cases and product needs you don't know about yet. Design systems, as a concept, are a centralized collection of reusable UX patterns, style tokens, and voice and tone guidelines that are applicable to many different platforms, whereas a component library is a collection of reusable abstractions for a specific experience. Component libraries are often confused for a complete design system, but not all component libraries are design systems, and not all design systems have component libraries. Some of the most popular open source component libraries implement design systems. We have Material UI, which is an implementation of the Material design system, Fluent UI, which implements the Fluent design system, and, for example, the Zendesk Garden React implementations are shareable components that implement the Zendesk Garden design system. The requirement for a design system to be flexible and unopinionated may not meet the use cases for your teams and the types of logic they need to share. The techniques shown in this course are applicable to design system components, but this isn't the main focus of the course. This is a self-paced course that will teach you the skills necessary to build a private component library with React and TypeScript. We will cover the core aspects of planning, building, testing, and deploying a private component library. Some of the technologies that we'll be using in this course are React, TypeScript, Storybook, React Testing Library, GitHub Actions, and GitHub Packages. The course content is split between 7 modules. In the first module, we'll answer what is often the hardest decision when starting a new component library, which is deciding which components should be shared. In Module 2, we'll learn how to create the initial scaffold of a component library with Storybook as our default development environment. In Module 3, we will learn some shared component patterns by creating a button component. In Module 4, we'll learn some more advanced shareable component patterns by creating an input and text area component. These will also include some accessibility features provided through React Context. In Module 5, we will learn how to create maintainable tests for our shared components using React Testing Library. In Module 6, we'll be creating a tree-shakeable build process with Rollup.js. And then in Module 7, we'll be setting up a CI and CD workflow within GitHub Actions to automate deployment of our component library to a private NPM registry. This course is written with flexibility in mind. I'll be recording the lessons in a macOS environment, but all the examples are applicable for Windows and Linux environments as well. We will be creating private repositories and packages within GitHub during this course, so if you don't have an account yet, you can create a free one, and all the usage within this course will be well within their free tier. During the course, we'll also be using the latest release of Node.js, which is v16. We'll also be using the latest version of NPM, which is v7 at this time. If your organization uses Yarn, all examples should be compatible with Yarn v1. We will also be requiring Git for this course, and if you don't have a preferred code editor, I strongly recommend VS Code, which has very good TypeScript integration. The first step in creating a new component library is identifying which components to build. With each team and codebase being unique, there isn't a hard rule on what should or shouldn't be shared, but there are techniques that can help you identify components that maximize developer productivity while still being flexible enough for a variety of scenarios. In this lesson, we will take a look at the concept of atomic design and learn how it can be used by library authors to identify shareable components. Atomic design is a design methodology created by Brad Frost. Originally created to promote consistency and scalability within design systems, it is a useful tool for identifying shared components in existing code bases. In atomic design, user experiences can be broken into 5 distinct levels: atoms, molecules, organisms, templates, and pages. Atoms are the building blocks of matter. In the context of a component library, atoms can include standalone HTML elements, as well as more abstract concepts like colors, typography, and spacing. Atoms are flexible, but they're often too abstract to provide a consistent user experience. Utility for CSS frameworks like Tailwind CSS can be a useful implementation for this concept. Above atoms, we have molecules, which are composed of smaller atoms. They can combine atomic styles like color and spacing with more complex concepts like accessibility, layout, and internal state. Some examples of molecules include buttons, inputs, radios, tabs, drop-downs, tooltips, and most other self-contained UI widgets. Molecules are the most common type of shared component. They're able to provide a consistent user experience while still being flexible enough for most implementations. Organisms, templates, and pages continue to build on each other to provide more complex experiences. These concepts work well for design systems, but often include business logic and other complexity that limits the flexibility of our component library. We will not be focusing on these component types in this course. Using the concepts from the previous lesson, it's possible to find shared components in even the most complex code bases. Let's walk through an advanced UI example and identify the different elements of atomic design. So here is the UX from the Azure database portal. There are a lot of different elements going on here, and it can be pretty complex, but to simplify it, let's break it down into the individual elements of atomic design. So starting with atoms, we can see some shared elements, including the shared color palette between componentry, font and typography that's consistent, spacing values that are the same within elements as well as between them, and then iconography that's shared across different areas of the page. One step above that, we can find molecules, which is where most shared componentry is going to live. And we can see things like icon buttons that are reused across the header and within the page. We can see removable pills that are reused in several areas. And then elements like buttons and these selects would be great examples of molecules that could be reused in many areas. If we look at another page, we can see some more consistent usages of things like organisms, templates, and page layouts. Within this course, we're also going to be providing a demo code base. This code base is going to be a showcase for components that are used in common application experiences, and it's going to include custom styling, but with Sass that we'll be migrating to our shared component library. These components will include things like buttons, inputs, and text areas. It's built on top of Create React App, TypeScript, and Sass, and we're going to be using this example to help identify some of the consistent styling and features that we'll want to include in the final component library. So to start out, download the code from the link provided, unzip the contents, and then open it in your editor of choice. I'll be using VS Code for this. So once you have it open, you can run npm install to install the dependencies, and then we can run npm start to start Create React App locally and view the demo code base. So once that's running, you should see page like this. So this demo code base shows a few different elements. We have buttons, which include some different style variants, and then we have inputs and text areas. The code base is split into a pretty common layout where we have, in our root, we have a single app component. And this app component is importing in a few different layout components, which includes buttons and field controls. So if we were to open up buttons, you can see some native HTML buttons being used, and then with custom styling applied through Sass. So this styling and componentry is what we're going to abstract into our shared components later on. So there is quite a bit of styling in this page, and we're basing a lot of it off of Bootstrap. And one of the hardest questions when you're separating components is what is global styling versus component styling. So not all page styling should be abstracted into these shared components, and that's just to make them as flexible as possible. So we want to avoid any styling that applies margin or other positioning constraints outside of our component. We want to avoid anything that overrides nested content styling and anything that enforces layout. So in this demo style guide, we have a mobile responsive grid provided by Bootstrap. So we don't want to apply any of that styling within the component. The typography and global spacing and resets are provided by Bootstrap, so we don't want to include any styling from that either. Some examples of component styling that are things that we want to include would be the internal padding within the buttons, any colors or states around the different style variants we have, like danger, primary, secondary, the sizing, whether it's full width or not, and the pseudo states like disabled, focus, and hover. And then some other global styling that we would want to avoid would be anything around typography or external spacing. So global styling isn't necessarily a bad thing to include in a component library, but it can cause issues with flexibility and reuse later on. So we're going to be avoiding it in this course. When creating any shared asset, the technologies that you choose will affect your consumers. This is especially true with front-end shared assets, including component libraries. In this course, we will be choosing dependencies that allow our component library to be used in a wide variety of React code bases. Within NPM, there are three types of core dependencies. Common dependencies, which are required by your application to be ran in production. Dev dependencies, which are only needed for local development and testing. And pure dependencies, which consuming code bases are required to install. Some common pure dependencies would be React and React DOM, which is due to them requiring a single instance and they can't be duplicated across different modules. When it comes to front-end application styling, there are a variety of technologies to style content. Sass, Less, and PostCSS are just a handful of the popular solutions available that produce static CSS. Component libraries can also use these same technologies, but providing static CSS for consumers can create complicated styling scenarios. Common problems include style specificity and ensuring that the component styles don't affect any other styles within the consuming application. Asset management and providing non-JavaScript assets may require consumers to customize their build configurations to use your component library. And bundle size impacts. With CSS, you often have to include a single file with all required styling. This negates some of the size savings that can result from tree shaking components that you're not using. For component libraries, CSS and JS is a common solution for these problems. It allows us to create our styles in the same way that we develop our React components and have all the benefits of being able to be tree shakeable as well. In this course, we will be using style components as our CSS and JS library. If your organization uses a different library like Emotion, these same concepts will apply. TypeScript is another technology that we're going to be using. It is a typed superset of JavaScript that helps find errors at build time. It's not only a benefit to us as library authors, but can also help document components for TypeScript and JavaScript consumers. If developers are using VS Code or any other TypeScript-aware editor, they will have auto-completion and prop descriptions even if they're not using TypeScript. GitHub has a generous free plan, which allows us to create private repositories, run a CI/CD environment, and host private NPM packages. The first step for a new component library is to create a private GitHub repository. When creating it, for the repository details, we can leave the owner as our personal GitHub username. And then for the repository name, let's call it component library. I've already created this repository under my account, so it's going to show as invalid for me, but should be good for you. Let's leave this as a private repository since we're creating an internal library. And then let's include a default README and a getignore with the Node.js template to start out with. Once you create that repository and clone it locally, open it in your editor of choice, which will be VS Code for me. And once we have this open, we can see the default getignore with the pre-populated Node.js values, which will be good for us in our NPM package, as well as a simple README. So to start out with, let's initialize our new package. So we can use the npm init command. So npm init force to pre-populate some of these values. So that command will create a new package.json that we can see here locally. And these values are pre-populated based off the repository that we have. And what we want to do first is update the name and the version. So for name, let's go ahead and add in our GitHub username as a package scope. For me, this would be Austin Green Dev, but it'd be whatever your personal npm or GitHub username is. And then let's make the version all zeros to start out with. The first dependencies that we're going to add in are the React-based peer dependencies, and we can include those by calling npm install, save peer, React, and React DOM. So by default, this will include React and React DOM with a open semver range for anything above the latest version, which is React 17 right now. To make this available to a wider variety of React code bases, let's actually change this to greater than or equal to version 16.12.0. So these minimum versions are determined from what React features we want to require based off of the features that we're using in our components. So we're going to be using hooks in our shared components, and so version 16.12 is a good starting point for those features. So this will allow anything greater than version 16.12 as well as version 17, which is the latest. Next, let's add TypeScript to our library. We also need to include the necessary type declarations for React and React DOM, and these packages are going to be included as dev dependencies since they're only required for local development. So we can call it npm install, save dev TypeScript, at types React, and at types React DOM. And then to help TypeScript understand our React environment a little bit better, we're going to create a new tsconfig.json file with the following content that you can copy over. So this configuration doesn't emit any JavaScript by default. It's only meant to do type checking when the compiler is ran. So now that we have a tsconfig included, let's create our first shared component. So we can create a new folder, source, and then within that, let's create a new folder called buttons. And then in here, we can create our first TSX element, which will be button.tsx. And we can include some default content here. So this button component is very simple. It's just going to return a button with some static text, so it isn't dynamic yet. To double check that TypeScript is running correctly, let's go ahead and run the TypeScript compiler locally. So with npx tsc, we can run that. And if there's no errors, good. It means everything's running correctly. So now that we have our first component created, go ahead and commit those changes locally just to store our progress. And in the next lesson, we're going to be creating a Storybook environment to help document and develop these components. In this lesson, we will be creating a new Storybook environment in our codebase where we can document and visually test our components. To add Storybook to our library, we can use the Storybook CLI. The CLI will look at our dependencies and create a default Storybook configuration for a React and TypeScript codebase. So first we need to run npx storybook sb init. And this command will create and modify several different files. So first it's going to create a Storybook directory with a main.js and preview.js where it helps us identify where the stories are located, which add-ons we're going to include, and some of the important things around how we render our examples. It's going to include a default stories directory that includes some default configurations and examples for configuring things in Storybook. It's also going to include some new dependencies and npm scripts for starting and building Storybook. So once that's finished, let's actually run npm install one more time. Sometimes it isn't completely done with this. And then once we have everything installed, let's call npm run Storybook. And this will start a local Storybook server on port 6006. And then once that's done, we should see this update. There we go. So by default, it includes several stories that showcase how you can document different elements. There's several different tools and add-ons here by default, but we're actually going to remove all of these to begin with. So let's remove everything under the stories directory, and then include a new introduction.stories.mdx file with this content. So this is an MDX file which combines Markdown with JSX, and it's going to allow us to render the contents of our README file at the root of the Storybook documentation. Next, let's document our button component by creating a new button.stories.tsx file with the following content. And this is going to include some default configurations around the title, so where the story exists, and the template for how it's rendered. So if we go to our button, we can see that it's showing our current button component, so hello world. And if we were to actually go into buttons and change the content to hello world 123, we should see it update locally. There we go. So let's go and remove that change. So the components documented in Storybook are rendered within an iframe. This is really helpful for testing components in isolation, but it may not be an accurate representation of the environment that will be consuming the component eventually. So in our demo style guide example, the components are styled with custom Sass styles, but the environment those styles are used in includes global bootstrap styling. These CSS resets affect how our component will be rendered, so we should be ensuring that our Storybook environment includes those same styles and resets. So to align our Storybook environment with our consuming codebase, let's add in a bootstrap dependency and include that styling in the preview.js file. So first, let's do npm install save dev bootstrap. And since this is only included in our Storybook styling, this is a dev dependency. And then in preview.js, we can import that bootstrap styling at the top. And then if we restart the Storybook server with npm run Storybook, we should see the styling reflected here with the bootstrap global resets once that's finished. There we go. So you can see it now showing the bootstrap global resets as default styling. There's a lot of different add-ons that you can include with Storybook. Some of the most popular ones are accessibility, console, Figma designs, or story shots, where you can do code snapshots from each story that you write. And they're really popular and really useful, but for this course, we're not going to be using them. Next, let's go and commit these changes and save our progress. And in the next lesson, we're going to be adding formatting and linting utilities to our code base. Enforcing consistent patterns and syntax is an important part of maintaining a component library. Code linting tools help enforce consistent code formatting and ensure that important code quality rules are being followed. In this lesson, we will be adding Prettier and ESLint to our codebase. Prettier is a code formatter with support for most types of files. It focuses on ensuring that our codebase follows consistent formatting rules like max line length and consistent comma usage. Let's install that with npm install save dev prettier. And this is a development dependency because it isn't necessary for it to run in production. Prettier comes with an opinionated set of default style rules, but for our library, let's create a Prettier RC file. And we can override the single quote rule so that way it's enforced across our code base. So now let's go into our package.json and we're going to modify this to include two new scripts. Let's start with format, which will run Prettier, right? And then let's also add in a lint step so we can make sure that our files are enforced by Prettier as well. So we can run Prettier check for that. So if we were to run format, npm run format, we should see all of our files updated to use the new Prettier syntax. Nice. And then we can run npm run lint format just to double check that everything is passing correctly. Cool. And so we can see in our diff here, we can see main.js and everything else has been formatted to match our Prettier config. Good. Next, let's go ahead and add in ESLint. So ESLint is a static analysis tool that allows us to ensure that our code follows specific code quality rules. By including additional ESLint plugins, we're able to reduce potential React and TypeScript bugs. So Prettier is mostly focused on code style, while ESLint, it does handle that somewhat, but it's mostly focused on code quality more than the individual style. So we're going to be using several plugins here. And let's go ahead and copy this over. And while this is installing, we can run through them. So we're going to be using TypeScript ESLint, both the parser and the ESLint plugin, to allow ESLint to understand our TypeScript files as well as JavaScript. We're going to be using the config Prettier plugin that allows us to reference our Prettier rules so ESLint and Prettier don't fight each other. And then we're going to be including the React and React hooks plugin, which allows us to enforce some React specific rule sets. And then let's create a new ESLint RC file. And this is just an opinionated default rule for us to start with. This is a root config that is using the TypeScript ESLint parser to parse the files. We're going to be using most of the recommended rule sets for all of our plugins. And then for the React plugin, we're going to let it detect the current React version from our package.json. One customized rule that we have here is React prop types. Since we're writing our components in TypeScript, this is going to be a little confusing to start out with, so we're going to just disable it for now. But we'll be using this rule set later on. And then in our package.json, let's add in a new script called lint. And we'll call ESLint source, so it lints everything within our source directory only. So if we run npm run lint here, we're actually going to get an error. Nice, or a warning. So our button.tsx file is missing a return type by default. So we can fix that by directly referencing react.function component. And so now that is the explicit return type for button, and that should fix our problem. Nice. So VS Code has some pretty good integrations with Prettier and ESLint. I've included the links to them in the doc, so if you don't have that set up yet, go ahead and add it in. But there's some really interesting helpers where you can actually disable rules or automatically fix things if it's possible to do so with the rule set. So now that we have ESLint and Prettier added in, let's go ahead and commit our changes and save our progress. And in the next module, we will learn some common shared component patterns and styling solutions by creating a new button component. In this lesson, we'll be improving the API of the original button component we created. Buttons are stateless and are one of the most common patterns on the web, which makes them a great showcase for common shared component patterns. In this lesson, we'll be covering API patterns that are applicable to all shared components. This includes JSX children pass-through, the React forward ref API, prop spreading with TypeScript and JSX, and providing opinionated prop defaults. A core concept of React is the ability to compose elements using the children prop. Shared component design leans heavily on this concept. Allowing consumers to provide children whenever possible makes it easier for them to provide custom content and enhance other components. It also helps align component APIs with those of native elements. Let's allow our button component to render its children. Before we start, let's run npm run Storybook to get our Storybook environment running in the background. The react.fc type definition that we included earlier already includes a children prop that we can reference. And we can pass this directly to the native button element that we're returning. One thing that this does change, since we were relying on that default text, the button doesn't include any content right now. So let's update our button.stories.tsx to now spread the arguments that it's provided and include some custom content. So let's do something like my button component. And we can see that updated. Nice. Next up would be the forward ref API. Many components have a one-to-one mapping to an HTML element. To allow consumers access to that underlying element, we can provide a ref prop using the react.forwardRef API. Providing a ref isn't something that is necessary for day-to-day React development, but it can be very useful within shared component libraries. It allows for advanced functionality, like positioning a tooltip relative to our button with a positioning library. Our button component provides a single HTML button element, which we can provide a reference to with forward ref. So let's go back to our button.tsx and remove the default type definition that we applied to it originally. And we can call react.forwardRef. And that's going to take two arguments. It's going to take a function with two arguments, the props, which we can leave the same as what we had before, and ref. Our ESLint plugin is complaining, since we are forwarding the ref, it wants us to provide a display name by default, so we can do button.displayName, and we can just name that button to begin with. And then for our ref, we can apply this directly to the button element. And this is going to error by default. So when we call react.forwardRef, it doesn't know what type this ref is. It isn't able to infer that type from where we place it. So we can provide a generic to forward ref HTML button element, and this should match the type of element that's returned from the ref attribute on the element that we're providing. So this is going to be a forward ref HTML button, and we can provide that to our native buttons ref. The next up is going to be JSX prop spreading. This pattern really increases the flexibility of our components, and it allows consumers to treat shared components as drop-in replacements for their native counterparts during development. Prop spreading can help with a lot of different scenarios. Accessibility and ARIA attributes are a really common thing that people don't include in prop sheets, and if you just extend the existing component set with prop spreading, it just happens automatically. Dynamic data IDs are another common one, as well as all the native events that you don't use day-to-day can be added in. Without prop spreading, each of the scenarios above would require explicit props to be defined, and this leads to something that I like to call the prop sheet of doom. It can be common to see components with prop sheets that include hundreds of individual props, and most of these duplicate native functionality or are only relevant for a very specific implementation somewhere in a code base. So prop spreading helps ensure that our shared component stays flexible as the native elements that they use internally. So let's add prop spreading to our button component. We can reference any remaining props that we have from our props here with destructuring, so we can get props. The issue that we have right now is there are no other elements inferred to this by TypeScript. So we can add in a second generic to forward ref called React props component props without ref. So since we're using forward ref here, this shouldn't be included in the other props. And we can pass it our button element here. And so now props will include all of the non-children props that are related to a button element. So we can apply these directly to our button by spreading them here. And this allows a lot of really unique things with TypeScript. So just to play around in our story here, since this is in a TypeScript environment, we could do something like an ARIA label that is working correctly. We can do an on-click event that's typed correctly and includes all the correct targets. So this would be a mass event of an HTML button element. And we can include custom data IDs like data test ID, for example. And more importantly, it will work if we include something that's invalid. So like type, since this is a button, there's only so many types available. Let's say we tried type of select, for example, which isn't a thing. That would fail because that's an invalid type. And then for our final shared component pattern, let's look at opinionated defaults. For certain components, you may need to default attributes to specific values. Whether it's to reproduce bugs or improve the developer experience, providing an opinionated set of defaults is often specific to an organization or team. If you do find the need to default certain props, you should ensure that it's still possible for consumers to override these values if needed. A common complexity found with button elements is that the default type value is submit, which is unintuitive, especially in a modern React world where we have buttons which aren't wrapped in a form often. So this default type can often submit surrounding forms accidentally and can lead to difficult debugging scenarios. So for our component, we actually want to default our type value to button. So let's go and add that in here. So we don't want to destructure it from our existing props. What we can do is just include a type of button. And then if someone provides their own type attribute, it would take precedence because it's after this type element, and that destructuring would reset it. So by default now, our button will have a type of button, and then if someone were to provide a type of submit, that would override it locally. So now that we have a basic shared API set up, let's go ahead and commit our changes and save our progress. And then in the next lesson, we're going to learn how to add style variants to this button component using style components.